Alright, so this one's not going to be too bad. It's an x cubed. So it says find all the zeros, but what's different about this is they didn't tell me anything to start with. So what I want to try to do is use my rational zero theorem to find all the possible ones I should be guessing with, so I'm not just out there all day long guessing forever. Alright, so let's take our factors of the constant term, which this is our constant term, 6. And then we want to put it over the factors of the leading coefficient term, which there's a known 1 there. So 6 is just going to be plus or minus 1. 1 times 6 is 6. And I just like to keep them in order, so that's why I'm just leaving a space. And then 2 times 3. The only way to get 1 is plus or minus 1. Our possible, now once we simplified this, because it's not always just a 1 down there, but 1 divide by 1 divide by 1, we just get all of our possibles are simply going to be not 4. That would be definitely a 6. Plus or minus 1, 2, 3, and 6. Alright, this is just basically our guessing field. When I do set up synthetic division, 1x to the third, 2x squared, negative 5x minus 6. Coming back up here to my original function, I can pick any one of these that I want to start with. I'm just going to start with positive 1. And I'm going to do synthetic division to it. Okay, you get negative 8. This is not 0, so 1 is not going to be a root. So positive 1, I'm going to say positive 1, and I'm going to put an x on it. I'm just going to try negative 1 next. Okay, I tried negative 1, and I was fortunate because it was a 0, so negative 1 is going to be one of our roots. And so I can rewrite that. If this is in x minus 1 format, when I rewrite it back into our polynomial form, it's going to be x plus 1 times whatever this left over is going to be, which if this was an x to the third, our answer starts with x squared x. So we're left with x squared plus 1x minus 6. Now, I have two options. I can either jump back up here and keep guessing 2, then try negative 2, 3, then negative 3, or I'm already down to a square now. Here we have methods for quadratics, so let's just use our bottoms up method. What multiplies to give us negative 6 adds to give us a positive 1. Let me bring this down, and then we have x plus 3, x minus 2. Let's just check that real quick. 3 times negative 2 is negative 6. 3 plus negative 2 is positive 1. So now we can solve. So this one's just going to be x equals negative 1, x equals negative 3, and x equals positive 2. So we found all the zeros of the function. Now initially we needed this starter. Once we get down to x squared, we're in familiar territory. And for an x cubed function, we only need to do that one time. For maybe an x to the fifth function, we might have to do it, keep being up here in our guessing pool multiple times until we find a few of the zeros. Alright, this is just extra for some practice. First of all, I just want you to list all possible rational zeros. And I'm going to give you the function to be f of x is equal to 3x to the fourth minus 11x cubed minus x squared plus 19x plus 6. We write factors of our constant term over factors of our leading coefficient term. All the factors that multiply to give us 6 all the factors that multiply give us 3. Now what I wanted you to notice is that when you divide these out, divide everything by 1, this one's the easy one that we've always had. That gives us plus or minus 1, plus or minus 2, plus or minus 3. Now, this other one is the one that we haven't seen. So, what is 1 divided by 3? Plus or minus 1/3. Then, what about 2? We get plus or minus 2/3. What's 3 divided by 3? 1, but we already have 1, so we don't need to write that. And what is 6 divided by 3? 2, we don't need that, so these are going to be all of our possible. I just wanted you to see an example when you might not only have a 1 down there. Okay, this is just an extra one too. If I give you this function, then we take plus or minus the constant term over the coefficient term. Here's our possibles. There's only 3. I'm going to start with positive 1 to try synthetic division. So positive 1 did not work. Let's try negative 1. Okay, unpause it and we see that negative 1 does not work. Let's try, we're going to pause it and try positive 3. And that didn't work either. Let's try the last one, which we would assume it's going to work, but let's verify that. And so finally we find the 0, so it's going to be negative 3, and what we're left with is going to be x squared x. So we want to bring this to the next page, or actually I may have room up here. So let's say if this is a solution, then it's x plus 3 when I rewrite it in this format, x squared plus 4x minus 1. Now, we'd like to use some bottoms up if we can, but what multiplies to give us negative 1 adds to give us 4? Nothing. That's not happening. So what's our default to fall back on when that happens? Quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Basically, you still have an option. So you would plug that in, and I'm going to let you do that on your own. And I would just tell you that the zeros of this entire function are going to turn out to be negative 3, and we got that one right here. Then when you put it in the quadratic, you're going to get negative 2 minus the square root of 5 as one of them, and negative 2 plus the square root of 5 as the other one. So I just wanted you to see something that was a little bit different so that you can be familiar with it.